session, and as per schedule, in this session, we'll discuss about ensembled machine learning that is also associated with deep learning. So whether we are working on some approach related to machine learning, deep learning, convolutional networks, we can integrate hybrid approach or ensembled approach. In traditional machine learning implementations or AI based implementations, you might have seen number of algorithms are available. Different approaches we implement, whether it is related to logistic regression, linear regression, or some clustering approach. But in whatever domain we are working, linear regression, support vector classifier. As far as ensemble or hybrid learning is concerned, in this segment, we move ahead to integration of multiple models. Integration of multiple models means you might have seen when we go for some research work, when we work on some particular data science based approach. If we try to integrate multiple algorithms, then we can elevate accuracy level, we can elevate performance level. In so many research dimensions, you might have seen that researchers or scholars try to develop a new approach like improved random forest approach or improved linear regression or hybrid approach. So in this particular session, we will see by which way we can work with hybrid learning using Python, that is also known as cocktail learning, mixture of different objects, mixture of different algorithms. In traditional way, in layman's point of view, we call as mixture of different objects, mixture of different approaches. In artificial intelligence, in technology, we call it as ensembled approach, hybrid approach, by which way we can integrate random forest with support vector classifier, how to merge naive Bayes classifier with logistic regression. First of all, we will discuss about the base concept related to ensemble learning, from where this particular term came to picture, by which way it is adopted in technology. If we discuss about this particular term ensemble, in general, it is related to music industry. You might have seen if a single musical instrument is playing, if some particular musician is playing a single instrument, it may be melodious or may not be, depending upon performance of that specific musician or music composer. But when we merge or when we play different types of musical instruments in parallel, which we relate with background music or background sound, when so many instruments are in process, then definitely that specific music composition will be melodious. Same thing is adopted in technology. Same approach is integrated in artificial intelligence for multiple applications, not only for data science or machine learning, deep learning, we can integrate it for cloud computing also. If you are working in blockchain, in that domain also, it can be associated in quantum computing also. merger of different algorithms, running or execution of different algorithms in parallel, so that we get highest level of accuracy. You might have seen that when we work on some specific algorithm, many times researchers stuck at a particular accuracy level. For example, I'm working on logistic regression. I'm having very good data set. It is trained, model is created, that's fine. But if we are stuck at 80% accuracy or 75% accuracy, then everybody knows that that specific work will not be acceptable. At least we should be having 84-85% accuracy in traditional machine learning. In deep learning, we have to move beyond 99% accuracy. We have to touch 99% accuracy or 99.99% accuracy. That's why researchers or practitioners try to merge different algorithms. Okay, can we merge ant colony optimization with honeybee approach? Can we integrate genetic algorithm with any other meta-heuristic approach? That is ensembled approach. That is ensembled learning or ensemble of algorithms, cocktail of algorithms. So we will see its demonstration also. First of all, we will discuss about different algorithms. And after that, we will see its hands-on real-time demonstration on our data set. As far as ensemble learning is concerned or ensembled of algorithms is concerned, there are two approaches, two segments. First segment, either we execute multiple algorithms in parallel, logistic regression with support vector classifier in parallel. That is bagging based implementation. If we are having n number of algorithms, X, Y, Z, A, B, C, D, 4 algorithms, and all of these algorithms are running in parallel on same data set, it means we are working on bagging approach. So what we do in that particular segment, highest level of performance from each algorithm is taken and finally it is merged so that we can elevate from 75% accuracy to 80%, 80% to 85%. In contrast, we can take boosting, that is sequential approach. One by one, we implement the algorithms. Okay. So these are different data sets available. Okay, so different links I have mentioned here, which we can explore for training of any model. Now, very first segment we will discuss here, that is bagging. Okay. Is it audible and visible to all of you? Kindly write in chat. Whether in chat only, kindly confirm. Is it audible and visible to all participants? Okay. So bagging algorithms. Very first segment. As you can see on this slide, in bagging based approach or parallel implementation, we create multiple models from different subsamples of training data set. So you can see here in this blue block, if we are getting results from SVM with 62% accuracy, from KNN 71, regression 81. But if we try to implement all of these three with merged approach, in ensembled way, we can move beyond to 85%. So by which way it is done? First of all, we will discuss about this point. Different subsamples of training data set. Multiple models we create of same type, but different subsamples. Okay, what is meaning of that? So I'm opening Notepad for explanation of this point. For example, we are having a particular data set in this way. Okay. For example, this is our data set. Okay. Just for an example, I'm specifying some values. Okay. Is this Notepad visible to all? For example, this is the data set we want to work with. Few more values we can take. So in bagging based approach, different subsamples. Subsample 1. Randomly we extract some values. For example, 8, 49, 4. This is first subsample. Second subsample, 12, 29, 5. Third subsample, in same way. Okay. 49, 10, 28. In this way. 3 different subsamples. And on these subsamples, on these individual data sets, we create different models, M1, M2, M3. In traditional machine learning, whatever algorithm we take, whatever algorithm we implement, we consider entire data set at once. We train entire data set in model. In case of ensembled approach, we do not take entire data in one shot. We create different subsamples, different blocks, and multiple models. So if M1 is created and it is giving 67% accuracy, okay, this is giving 95% accuracy. In same way, it is giving 78% accuracy. Finally, we perform a statistical operation or any mathematical operation we can implement. Same thing mentioned here. Different subsamples of training data set, multiple models, and final output prediction is calculated by averaging the predictions. Okay, whatever operation you want to perform, it depends on research objectives, whether we want to work on average or maxima or minima or standard deviation, which type of operation we want to implement. Okay. So first of all, we are discussing about different segments, different approaches at base level. We are covering the concept. As far as implementation is concerned, code snippets are available. I will show you that part also on our data set. But before that, we should be clear about the base concept, different perspectives, how to work on such type of implementations. And if you are clear about such type of approaches, then you will be able to merge any algorithm. We can merge any number of algorithms, whether these are related to machine learning or deep learning. Random forest approach. If we discuss about different examples of bagging approaches, very popular algorithm is random forest approach. You can take bagged decision trees or extra trees. Now we will see by which way random forest approach works in parallel implementation. What is meaning of different subsamples of training data set in random forest approach. We will discuss about this point. Okay. So you can see in this slide, first of all, we should be clear about this point that all of us use random forest approach for decision making. Every human being, whether that person is literate or illiterate, whether that person is technical or non-technical, all of us makes use of random forest approach for decision making. In same way, every professional, whether that professional is medical professional or legal expert, each and every subject expert or professional use random forest approach for decision making. So with this example, we will discuss, we will understand what is the way of working with random forest approach, by which way sampling is done, and after that you can implement it on any type of data set. So you might have seen in case of doctors, medical practitioners, whether that expert or medical practitioner is beginner or specialized, each and every person, each and every doctor is having a specific data set in their mind or in their clinic. For example, just for an example, we are taking from A to G. These are different names of medicines. Okay. You might have seen when we move to some clinic, they are having their own set of medicines. They suggest or recommend their own medicines. And obviously, they are having a particular set of medicines in their mind or in their repository. We can relate it with their data set. Okay. For example, from A to G. So what happens when we move to doctor with some particular problem or some symptoms? When a patient moves with some symptoms, what doctor do at that particular point? On day one, some medicines are given randomly, some medicines are provided. Okay, you take A, C, and D and come after 2 days. Every doctor perform it, whether it is North India, South India, or any other country. Very first day, some medicines are provided, some medicines are recommended, and then it is also told that, okay, come after 2 days for rechecking, for re-evaluation. Then day 3, if that particular patient says that, okay, I'm fine, but not 100%, you might have seen in that scenario, that particular doctor changed the medicines. Okay, rather than D, this time you take A, C, and F, and again come after 2 days. And by this way, multiple iterations are implemented. And finally, when that specific patient is okay, then it is counted, okay, highest number of votes A, highest number of votes C, and D. So this is the final method. This is the final prediction. So what is this particular scenario? On day 1, this is model 1, this is model 2, this is model N. Multiple models from same data set, but in subsamples. Model 1 is not taking entire data set at once. Model 2 is not taking entire data set for training. Each and every model is taking random data set and performing hit and trial. So it is hit and trial based process. Are you getting this point? Is this point clear to all of you? Are you getting whatever we are discussing here? Kindly write in chat. Multiple models, multiple outputs, and after that, we check with some statistical operation. It may be averaging, it may be maxima, it may be minima, depending upon that particular scenario. Okay, are you getting this point? Kindly confirm, kindly write in chat. Whatever we are discussing here, okay. Now, if we discuss about second segment related to ensemble learning, that is boosting algorithms. In case of random forest or badging based approach, that is parallel, that is performed in real time, in synchronization. When we implement boosting approach, boosting algorithms, it is sequential in nature. Same thing is implemented here, multiple models of same type, but in sequence. Multiple models, M1, M2, M3 up to Mn, in sequence. And major difference with bagging is that when we will move ahead from M1 to M2, from first model to second model, we keep on checking the errors in previous model. In every iteration, in every next phase, we remove errors from previous model. So for example, you can see that in this particular data set. So these are inputs 1 to 4, this is under class 0, 2, 4, 5, this is under class 1. Okay, multiple values and their different classes. Individual model. Okay, individual model is training that particular data set and it is giving predictions. As there is one query, what individual model is doing. Individual model, each and every model is working separately. With every model, definitely there will be some error factor, there will be some accuracy value. And what we do in first model, in M1 model, for example, this record is incorrectly classified. For example, 0 is incorrectly classified in M1. So what we do in case of M2, we assign highest weight to this particular class, to this particular record. Additional attribute is added in M2 second model, and highest preference, highest weight or priority is assigned to that record that was incorrectly classified in previous model. So as far as algorithm is concerned, ADA boost, adaptive boosting. In previous model, if this 4401, okay, its actual class is 1, but in M2 model, it is incorrectly classified. Then we increase its weight and decrease weights of other classes, other records. And in previous slide, okay, what every model is doing. Okay, is this your query in this particular random forest approach? Yes, we use supervised algorithms. In ensemble learning, we use supervised approaches because we have to find out accuracy, each and every model. So this model is finding accuracy. For example, day one, ACD, patient is not cured, only 30% accuracy is there. In ACF medicine, 70% accuracy. In ACD, 90% accuracy. So by voting, we check, okay, how many votes are in favor of some particular output, how many votes are in favor of some particular value. Is this clear? Kindly confirm. Each and every model, yeah, we do not use unsupervised model in ensemble learning. Generally, we do not use. Why? Because in case of unsupervised models, it is difficult to find out accuracy level. It is difficult to find out the actual class because it is random in nature. Okay, if we will perform that implementation n number of times, in that case, outliers will be different in every iteration, in every phase. But in case of supervised learning, we already know, okay, its actual class is 0 under 1 to 4, but it is incorrectly classified. So this is also related to fine tuning. In deep learning, you might have heard about that particular term, fine tuning of model. Fine tuning means we are tuning or optimizing or updating that model in such a way that using same data set, it will give highest accuracy. No need to change data set. Many times it is seen, you also might have seen when we work on some algorithm, okay, some researcher is having a very good data set. They have already defined their research objective with particular algorithm, but they are stuck at particular accuracy. In that case, it is not good approach to change data set. Many times what is done, researchers try to modify data set in such a way that it will give high accuracy, which is not ethical. This is known as statistical fallacy. Modification of data set in such a way that it will give highest accuracy, or changing that entire data set to get high accuracy. It is not a good approach. Better approach is to use mixture of models. If I am not getting good results in support vector classifier, then we can integrate regression with that. And with that approach, we will be having improved SVM, or you can relate it with hybrid approach, hybridization. And so in so many research work, such type of implementations are done. Integration of convolutional networks with GRU, with GAN, integration of GRU with LSTM, integration of 1D CNN with 2D CNN. It is not manipulation. It is not only, it should not be related to manipulation of data set or manipulation of algorithm. It is basically fine tuning. To fine tune existing approaches. Okay. Up to this point, is it clear to all? To this point, is it clear to all of you? And are you getting all of these points clearly? In chat, kindly confirm. Very soon we will start that demonstration part. Okay, And hybrid approach and boosting same. Yeah, definitely. Hybrid approach and boosting, these are interrelated. Okay, because under hybrid there is bagging and boosting. Okay, hybrid means merger of two or more approaches. So it depends on that domain whether we want to work in sequential way or parallel way, but it will come under hybridization. So different algorithms available, bagging methods, random forestries, ADA boost, gradient, tree boosting. Okay. Now we will see types of voting which are performed in ensemble learning. So as we have discussed that from same data set, we create multiple models. For example, one model we have created for regression, second for KNN, third for Gauss-Naive Bayes, another for SVM. Multiple models we have created. Finally, how to collect output from each model? From each output, from each prediction, by which way we can merge results. So first is hard voting. First technique. So it depends on you whether you want to go for hard voting or soft voting. Hard voting means directly we go for calculation of highest number of votes. For example, M1 is giving output with 1. So one is the final class. M2 is giving that, okay, this particular record should be in class 1. M3 is giving output that it should be in class 0. So we will ignore this because highest number of votes are in favor of 1. If we are having some data set, in that particular data set, some records are classified. Definitely there will be classification. Okay, there will be some prediction value. So we check, okay, to which particular prediction there are highest number of votes. Hard voting. And soft voting, in this scenario, we calculate probability, highest probability. Okay, for example, one record is classified as 1 in class 1 with 80% accuracy, with 80% probability. 0, definitely 20%. So averaging of 1, rather than counting only highest number of votes, we perform average. Okay, what is the average of ones? Classification under class 1. And finally, we check that point or that prediction. Okay, so if you are new in this particular domain, we can work on such scenarios. Okay, like comparative evaluation of voting ensembled techniques, comparative evaluation of different voting approaches. So same data set we can take, on same data set we can implement soft voting, on same model we can implement hard voting, then we can check its execution time, accuracy, prediction value, prediction probability, performance, root mean square error, and then we can identify which technique is giving better results, whether soft voting or hard voting. Okay. Both approaches are fine. If we want to take very fine quality results, interior results, if we are having a complex data set, large data set, In that scenario, we go for soft voting. For complex data set, for traditional data set, we can take hard voting. Okay, so in general, soft voting for complex data set and hard voting for traditional. For sensitive applications, we go for soft voting. Sensitive applications means medical images, medical data analysis, geosatellite data analysis. These are sensitive applications. Defense based research, that is sensitive data. In such scenarios, we go for soft voting. If we are having traditional data set, then we can go for hard voting. Okay. Now we will see the demonstration part, by which way we can work on hybridization based technique, that is related to ensemble learning. It is also related to fine tuning. It might be looking a debating topic. Many times there are some debates about this particular topic, that randomly we are merging algorithms to get high accuracy. Is it ethical or unethical? Is it valid or not? But in so many instances, in so many scenarios, in almost every domain, you might have seen there is hybridization. Even nowadays, you might have seen that in computer science, in IT, in algorithms, approaches from other domains are adopted. If we discuss about ant colony optimization or honeybee approach, honeybee or ant colony, these are not related directly to computer science. These are nature inspired algorithms. But by analyzing their behavior, by analysis of behavior of some creature, we have adopted it in form of an algorithm. Simulated annealing. Annealing is a topic related to metallurgy in production engineering, but it is used in computer science. It is used in algorithms. Okay, so we should not think that merger or adoption of some approach from other domain can't be done. Depending upon area, depending upon that domain, we can see, okay, whether same thing we can implement using a new approach that is available in any other domain, that is available in any other subject. Same thing here. If logistic regression and decision tree classifier is not giving good results, can we integrate KNN with that? Can we integrate support vector classifier with that? If in research objectives, we have already mentioned that we will use improved KNN, then either I will be able to improve mathematical model of KNN, or we can integrate any other technique. So from same data set, multiple models will be implemented, and then best output, best prediction from each model. That is ensembled approach. Okay. So now we will see its demonstration part. For demonstration, I'm opening Google Colab. In Google Colab, we will see so this is the code snippet. of ensemble learning, we will see description. We will discuss about this code also, by which way we can work with ensemble learning in Python. And this code we are running on Google Colab. Is this visible to all of you? Is this visible and audible to all participants? I'm increasing font size. Is it visible to all of you? Kindly confirm. Okay. Now see this very carefully. First of all, we have to import sklearn library. Sklearn, you also might have worked on this platform, on this library, that is scikit-learn, specialized for machine learning, for data analysis. In scikit-learn, different algorithms are already programmed, including ensembled technique. So you can see that if I want to work with the decision tree classifier, it is imported, support vector classifier, and this is sklearn.ensemble. Okay, it means that it is a valid approach. It is a valid way of working with hybridization, because many times there are debates that we are merging X with Y just to get high accuracy. We are merging A with Z just to get high performance. But it is a valid way of working. And this approach is implemented everywhere, in every domain it is adopted. Voting classifier, Gaussian naive Bayes classifier, KNN, voting classifier. Okay, now we will see, first of all, we will see results from individual models. We will implement decision tree classifier separately, logistic regression separate, SVC, Gaussian naive Bayes. Individually, we will implement algorithms on same data set. Which data set? So this is the data set of banking, very popular benchmark data set related to bank customers. Okay, this particular file is available on GitHub, Kaggle, as well as on machine learning repository. Okay, so at end of this session, I will give this data set and code to all of you. So to upload data set on Google Colab, we use these instructions. From google.colab, import files and files.upload. Okay, we will upload this data set. This is churn modeling data set, same file, and now you can see that we will, first of all, we will create different models. 5 different models. Currently, it is not hybrid. First of all, we will execute it independently to check how much accuracy we are getting. After that, we will merge. Then we will see whether accuracy or performance is getting increased or decreased. Okay, so model 1, logistic regression. Model 2, decision tree classifier, and its depth is 2. From model 1 to model 5, these are individual models. Each model is fit separately. Now you can see that up to now there is no hybridization, there is no ensemble, because we want to see accuracy without ensemble. After that we will see accuracy with ensemble. Okay, model 1 is fit separately. This is training data and predictions. You can see that each prediction is going on with each model separately. Model 1 is predicting in this variable, and confusion matrix is also generated for each model in separate. Okay. And we will see accuracy of these. So I will run this code, and that file I will upload here for that data set. Okay, so any file you can take desktop and churn modeling. Now data set is getting uploaded, and very soon we will see the prediction accuracy level at individual model. Okay, so now this file is getting uploaded, and now you can see that this is the output from individual models. Okay. So output from logistic regression is this 81.10% accuracy. Decision tree is giving 83.11% accuracy. This is out of 1. Okay. If we will calculate percentage, it will be 83.09% accuracy and 82.43%. Individually, we are at this point in highest. Individually, decision tree model, decision tree based prediction is giving highest accuracy, that is 83.11%, or out of 1 we can say 0.8311, so on. Now we want to check, we want to make it hybrid. What will happen if we merge it? If we try to merge these, then can we move ahead to this highest value? So you can see at in next cell, we have created multiple submodels. Now, this is the scenario where hybrid ensemble learning come to the picture. Create submodels. First of all, this estimators. Estimators, initially it is empty. Initially, there is no model. Now, you can see 5 times logistic regression models, 5 instances of logistic regression. Rather than single logistic regression, we want to fine tuning. We want to make it enrich 5 times. 5 times decision tree classifier, and in each classifier, we have modified depth of that tree. Is it visible to all of you? Multiple mixtures. Now we are creating mixtures of algorithm. So this is mixture of logistic regression with decision tree, some proportion of decision tree, some percentage of support vector classifier, some particular part of naive Bayes, and every model is appended in estimators. So estimators.append. Initially, estimator is empty. You can see, and after every instance, this particular estimator is getting values, okay, append. Now, different variants of support vector classifier. Different variants of support vector classifier. In first variant, we are working with linear kernel, then polynomial, radial basis function, then linear. It might be looking like a mixed wedge, but in research and development, it is very common approach for mixture that is related to integration of multiple models. You might have studied so many research papers related to hybridization of genetic algorithm with simulated annealing with ant colony optimization, with Loen optimization. That is also ensembled approach. Okay. And it should not be done in haphazard way. We have to check whether this combination will give some good result or not. In chemistry also, you might have seen, in chemical labs, you might have seen that scientists keep on mixing different chemicals so that they can work on a new type of medicine. It is not manipulative way. Mixture of medicines, mixture of different objects, mixture of chemicals. Same thing in computer science, same thing in technology, mixture of algorithms, 5 KNN, multiple times Gaussian naive Bayes, and finally voting. And after voting, it will check the final output. So if we execute it, obviously it will take more time, because if so many algorithms will be executed in parallel, then definitely it will take more time. It will be complex, but it will give you high accuracy. So in this case, you can see 83.62% accuracy. In individual way, in individual implementation, we were stuck at 83.11. In hybrid way, in ensembled, in mixture, we are getting this 83.62. And we can play with it. We can delete some estimators. We can add some estimators. We can add some additional algorithm. We can integrate some more algorithms, and by hit and trial, because if we discuss about research perspectives, you might have seen that generally we have to work with hit and trial based approach, whether it will work or not. Okay, it is not workable, then okay, whether this is working or not, whether it is working properly or not. Hit and trial of different mixtures. At the time of COVID, initial time of COVID, you might have seen when vaccination was not available. That was the time of that trial. That was the time of hit and trial. Every company was working on different type of mixtures. Okay, can we mix this with that mixture so that we can get medicine? Okay, it is not working. Okay, can we mix these liquids? Can we mix these chemicals? And is it possible to create vaccine or medicine or remedy of this particular disease? In medical science, it is very frequently implemented. In chemical industry also, it is very frequently implemented. In automobile industry, in production engineering, you might have seen it is very common. In IT, in telecom also, it is very common. Spare part or component of some particular device, some specific gadget, its mixture with some other gadget. Can we mix with that or not? Is it possible to reuse it or not? In everywhere, wherever you can think, everywhere this approach is implemented. And as far as thumb rule is concerned, there is no thumb rule for mixture. It is basically a matter of experiment. We have to keep on working with different variants. So what we can do, in which way we can work with that? For example, we are working with SVM, okay, SVM, RF, Gaussian naive Bayes, okay, and we are having KNN, and this is accuracy. This is accuracy, okay. We can see, okay, how many instances? 3, 2, 4 instances. This is accuracy. 26, okay. So by this way, we can create an Excel sheet by which how much accuracy it is giving, and by that way we will be able to conclude with a result that this type of combination is better. We can plot it and we can find out a formula for identification of best results. Okay. So are you getting this point? Kindly confirm whether is it visible and clear to all participants. Are you getting this point? By which way ensembled approach is implemented with merger of multiple algorithms. I'm sharing this notebook to all of you. As far as number of instances are there, as there is one query, why so many instances? There is no thumb rule. Again, we are pointing out that no thumb rule. Okay, so you can modify it. You can take 2 variants of KNN. We can take 3 variants of logistic regression. It is a matter of experiment. Okay, it may be possible that with less number of variants, with less number of mixtures, we will get high accuracy. It is just for demonstration that we can perform it in this way. Okay, just for an example, it is shown that we have used. Okay, and as far as best instance is concerned or best output is concerned, so as just now we have used our notepad file, so we can create a data set. Okay, if 5 variants of naive Bayes and 4 variants of KNN, 3 variants of this is the accuracy. So we have to keep on working. We have to keep on exploring different variants till we are getting better output. Same thing we can relate with the chemical industry. Okay, so chemical experts also perform same thing. They keep on mixing, they keep on experimenting different chemicals, different salts to make a specific medicine or to prepare a separate reagent. So there is no thumb rule. It is a matter of experiment how to work on that part. So I'm sharing this presentation to all of you. Along with this code. So, dear participants, link of the presentation and code I'm sharing in chat. Please click on this link and download presentation and code and confirm whether it is downloadable or not. Simply click on this link. As there is one query, when all instances are mixed in estimators at the time of voting classifier. So you can see that I'm resharing my screen. So here you can see that ensemble and voting classifier. Now, okay, up to now, estimator is getting filled with so many models. Finally, from that estimator with so many models, voting is implemented. So which type of vote you want to perform? Hard voting or soft voting? And as far as RBF or polynomial is concerned, RBF is used for complex data set, for some data related to matrices. Polynomial we can use for traditional data sets. So, dear participants, kindly confirm whether this link is getting files or not, whether you are able to download files or not, and how to know which instance was best. So again, I'm repeating that point, that it is a matter of experiment. You have to create an Excel sheet. We have to create a particular formula from different variants, that if this is the formula, 2 variants of SVM, 3 variants of this, what is accuracy? And with that particular data set, we can implement data science or statistical functions. Kindly confirm whether this presentation is downloading or not. Presentation and code is getting downloaded or not. After downloading, write done so that we come to know that you are able to download this presentation. If you have any query, you can unmute or you can write your query in chat. If you want to ask anything, any query, you can write your query in chat. If you have any query, you can write your query in chat.